Okay, so we've looked at the relationship between the Earth and the Sun during four periods of the year: March 21st, September 21st, which is fall and spring equinox, June 21st, which is the summer solstice, and then December 21st, which is the winter solstice. Okay, now let's figure out, let's do some of these problems that I'm asking you to do, and I'm just going to do one as an example. And let's examine how we find our location if we know the angle of the sun, okay? And the way people knew the angle of the sun is they would take sun measurements. There's something called a sextant, right? And so at noon, okay, you have to do this at noon because you know what time it is at noon. But when the sun is directly up above your head, that is solar noon, okay? So that's kind of your base point, if that makes sense. But they would take measurements, okay, using a sextant, which measures the angle of the sun. If this is the horizon as you're looking across the earth, it measures that angle between where the sun is and the horizon, okay? So let's just do an example here, and we'll use our illustration of the earth and sun here to figure out our location, okay? So let me read one problem here. I believe it says, problem number 3, imagine you are on one of, or excuse me, suppose you're sailing in the Pacific Ocean on September 21st, and you measure the angle of the sun above the horizon at noon to be 75 degrees. What is your latitude? Okay. All right. Well, let's draw our triangle. We know it's September 21st, right? What does that mean? Where is the sun's rays hitting the earth vertically? At the equator, okay? So let's just go ahead and make our triangle. So what's the information that we know? We took a reading with our sextant, and we know that the sun's, wherever we are at noon, the sun's rays are making a 75-degree angle with the horizon. So I'm just going to draw, I don't know where we're at. We're somewhere on the earth. You know, we could be anywhere here, and I just drew a line marking the angle of the sun, okay? And I'm going to draw a horizon, okay? To make our triangle. Okay, here's our triangle, right? Wherever we're at, we know that it's a right triangle, right? Because the triangle is making a 90-degree angle with the horizon. So this is 90. We are trying to find this, okay? We're trying to find our location on the earth. And we know, what do we know? Well, we know that this angle from reading our problem is 75 degrees, okay? We know that. Opposite adjacent angles are equal, correct? Therefore, this angle is 75 degrees, okay? So we know a right triangle adds up to 180, so we can just do the math now, correct? So 90, 75, we need to find, we're trying to find this angle, okay? Right triangle is 180 degrees. Let's add 90 and 75. That is 165, right? Subtract that from 180. 15. 15, that means, what does that mean? It means this angle is 15 degrees, okay? We are at 15 degrees north latitude. That's where we are, okay, 15 degrees. So I kind of drew my triangle a little out of whack. You know, my triangle should actually be down here, okay? all right? Should be actually down here, okay? 15 degrees. Makes sense, right? September 21st in Casper, Wyoming, as we've seen in the other videos, the angle of the sun is 47 degrees. We know the angle of the sun at the equator is 0, right? Because it's directly overhead on September 21st. Therefore, if it's a 75-degree angle, that means it still has to be pretty high in the sky. So 15 degrees, okay? So we are somewhere 15 degrees north latitude. That's pretty close to the equator. We're probably somewhere warm, somewhere tropical, okay? Again, this is how you find your location, okay? Based on knowing the angle of the sun. You just kind of work backwards with your triangle, all right? Based on that, you should be able to answer some of the other questions given the angle of the sun, okay? Here in a second, I'm going to pause the video and kind of get ready for the next part. But in the next part, we're going to see if we can develop an equation to figure this out without having to draw a triangle, okay? And that has to deal with the analemma. So I'm going to pause the video and I'll be back in a second to explain about the analemma. Okay, so let's talk about another way we can figure out angle of the sun and our latitude and all of that. And we just learned how to do that using illustrations by creating a right triangle on the earth and figuring out the angle of the sun. And if we know the angle of the sun, we can find our latitude. And if we know our latitude, we can find the angle of the sun. Let's talk about an equation that could help with all of this rather than having to draw it all up on a piece of paper on the board like I've been doing. And the way we have to do that is with the analemma, okay? And you guys should all have a copy of this. I put it in the Word document on Moodle. But let me explain what the analemma does. The analemma tells us where the subsolar point is on the Earth. In other words, what is the subsolar point? The subsolar point is where the sun's rays are hitting the Earth vertically, okay? That's the subsolar point. And what the analemma tells us is on what date does that subsolar point occur. Okay, so for example, one of the problems we did was what's the angle of the sun in Casper, Wyoming on September 21st? Okay, lost my train of thought here. Okay. Sorry about that. Regain my train of thought here. Again, to reiterate, the analemma shows on what date, on a certain date, where is the subsolar point? Where is the sun hitting the Earth vertically with its rays? Okay, so for example, let's do an easy one, September 21st. So if you find September 21st on the analemma, and I'm just going to circle it with my red pen here. Right? September 21st, you can see where is the subsolar point? It's at It's at 0 degrees. It's at the equator, right? And we've already determined that, right? Remember when we showed the relationship between the sun and the Earth on September 21st or March 21st, where was the sun's rays hitting the Earth vertically? It was at the equator, okay? Again, find March 21st on the analemma. Where's the subsolar point? Again, my other circle there, it's at the equator, okay? Let's do another one. Where is the subsolar point Where is the sun's rays hitting the earth vertically on June 21st? Tropic of Cancer. All right. Where is the sun's rays hitting the earth vertically on December 21st? The Tropic of Capricorn, right? Okay. So that's what the analemma does, is it shows you for a specific date where that subsolar point is. Okay. Now, some of you might be asking, why is the analemma shaped like a figure eight? Why isn't it just in a straight line? Okay. Well, there's two reasons for that. Number one, the Earth is tilted on its axis 23.5 degrees. Okay. If I have my globe here, the globe isn't situated like this towards the sun, right? This markers the sun. Okay, the Earth is tilted 23.5 degrees. Okay. The other reason that the analemma is in a figure eight is because the Earth doesn't orbit around the sun in a perfect circle. The Earth's orbit is oblong. Okay. The Earth is, I believe this is correct, the Earth is closer to the sun in the winter, and it's farther away in, let me look at my analemma actually, and it's farther away in the summer. I believe that's correct. Okay. That is why if you look on your analemma, there is sun fast and sun slow. So those numbers at the top here, those are in minutes. Okay. What does that mean? It means, so for example, if you look at your analemma, and let's look at March 16th, or excuse me, what is that? Is that a 6 or 5? It's March 15th. Okay. Look at March 15th. And if you follow that line up to the top, notice it says sun slow 10 minutes. Okay. So what does that mean? It means on March 15th, if you go outside at noon, the sun isn't going to be directly overhead. It's going to be a little bit slow. Okay. It's actually going to be 10 minutes slow. Okay. So it's going to be 10. It actually solar noon on March 15th is at 11:50 a.m. Okay. 11, or excuse me, no, I have that backwards. Solar noon on March 15th, sun slow, is actually going to be at 12:10 on your watch. Okay. It's not going to be at noon. It's going to be 10 minutes slow. So it'll actually be at 12:10 p.m. Okay. And that is because the orbit around the sun that the Earth takes is oblong. Okay. All right. If it was a perfect circle, we wouldn't have seasons. Okay. Things would be a lot different than what they are now. Okay. But that's the reason. And you can make your own analemma. It'll take some time. But for example, you could go out. Let's say you had a flagpole, right? Or some kind of stone structure like a tower in your backyard. If you went out at noon, okay, once a month, like let's say the first of every month, and you went out at noon and you put a rock where the shadow is, around that flagpole or that stone structure or that tower that's in your yard made out of stone. If you do that for an entire year, the rocks that show where the shadow is, it's going to make an analemma. The rocks aren't going to be in a straight line. They're going to be in a figure eight, and you'll make your own analemma. Okay. So now that we have explained the analemma, now we can start to make an equation to solve all of these problems, okay? And there's my equation right there. Angle of the sun equals 90 degrees. Subtract that from our latitude plus or minus our SSP. Now, if you have watched, how do we know whether to plus or minus our SSP? We add the SSP in the winter and subtract the SSP in the summer. Okay, if you've watched the previous videos, if you look at our triangles that we made, if the problem had to do with in the summer, we always subtracted the SSP, whatever that SSP was, wherever the sun's rays were hitting the earth, okay? Let's do an example. Let's find the angle of the sun, okay? So let me write my equation at the top of my paper. Angle of sun equals 90 minus our latitude plus or minus our SSP. I want to know what the angle of the sun is in Casper, Wyoming, and I'm just going to pick a date I'm going to pick October 30th. Okay, what is the angle of the sun in Casper, Wyoming on October 30th? Okay, so here's my equation. Angle of sun equals 90 minus our lat plus minus our SSP. Okay, what's the angle of the sun in Casper, Wyoming on October 30th? Well, let's plug in what we know. We're trying to find the angle of the sun. We'll call that X equals 90 minus our latitude. We know our latitude for Casper is 43 degrees. What is that? Now we need to know the SSP. Where does the sun's rays, what's the location where the sun's rays hit the earth vertically on October 30th? Well, let's find October 30th on our Analemma. I'm going to put an X on it. So where is October 30th? There it is. Okay, there's October 30th. And it looks like the SSP is at, what is that? 13 degrees, right? 13 degrees. That's where the sun's rays at 13 degrees, okay, south, 13 degrees in the southern hemisphere, 13 degrees south of the equator, that's where the sun's rays are hitting the earth vertically. Is that winter or summer? Well, we're past the fall equinox, right? So it's going to be winter. So we are going to add the SSP, okay? So we're going to take our latitude 43 plus 13. So here's what my equation looks like now. X equals 90 minus 43 plus 13. What's 43 plus 13? It is 56. X equals 90 minus 56. And that is 34. X equals 34 degrees. What does that mean? It means in Casper, Wyoming, on October 30th, if we go out and measure at noon, the sun's angle from the horizon, it will be 34 degrees, okay? And if you think about it, that makes sense. On September 21st, the angle of the sun at Casper is 47. On December 21st, if you work through the problems, the angle of the sun at Casper is going to be 23.5. So it stands to reason that that angle must be somewhere between 47 and 23.5. And sure enough, it is. It's 34 degrees. So I hope that equation makes sense. Angle of the sun equals 90 minus our latitude plus minus the SSP. We add the SSP in the winter. We subtract the SSP in the summer. Okay. All right. Hope that video helps.